Hello and welcome everyone. Thank you for joining the Semiconductor webinar, Unlocking RFID Microchip Innovations for Industrial and Healthcare sessions today. My name is Tan Prasoprat, a Senior Sales Engineer here at Semiconductor. I'll be your host for today. Here's a quick look at our agenda. First, we'll explore the RFID chips applications in semiconductor, waste management, and electronic key management. Then we'll cover factory automation, machine and device safety, and surgical operations. And finally, we'll wrap up with the Q&A sessions. Throughout the session, feel free to leave your questions in the chat, and we'll answer the selected ones at the end. Now, let me introduce our speakers for today. Ms. Parada Shlamat, Lead Customer Application Engineer, and Mr. Chayason Somjit, Customer Application Engineering Manager. Before we begin, I would like to introduce our new products for our portfolio in 2025, which includes low-frequency chips, SAC73F1 and SAC7150, and high-frequency chip SAC56NL. Now, let's begin with the first topic on today's agenda. Ms. Parada, please go ahead.
Hello everyone, my name is Parada Shlamat, Lead Customer Application Engineer. Today, I would like to show you the application that use RFID in the industrial IoT from 3 applications. First, RFID in semiconductor. Second, RFID in waste management. And the third one is electronic key management using RFID. Now, let's explore how RFID technology is being applied in semiconductor manufacturing, especially during wafer fabrication, one of the most critical and complex phases in chip production. Wafer fabrication involves hundreds of precise steps, such as oxidation, ion implantation, etching, and deposition. These steps are performed in clean room environments with advanced automation systems. Managing all this requires real-time tracking and data logging at every stage. Traditionally, fabs have relied on barcode or manual systems to identify and track wafer carriers, but these methods have limitations. They are line of sight, slower, and more prone to human error. This is where RFID comes in. By embedding RFID transponder into 12-inch wafer carrier, fabs gain a non-contact, high-speed way to identify and communicate with each carrier. Each RFID chip contains a unique identifier and can store process-related data directly on the carrier. As a wafer carrier moves through the fab from one process station to the next, RFID reader installed at each station automatically detect the carrier, read its ID, and update fabrication data. This enables machines to dynamically adjust process based on the carrier history. For example, if a wafer carrier misses a step, the system can flag it in real time and reroute it as needed. Or if a process tool has a known defect, the RFID data allow precise tracing of which wafer were exposed, critical for yield analysis and quality control. According to Semiconductor standards, RFID technology will be implemented in the 12-inch wafer fabrication process to enhance traceability and automation. The RFID reader will be installed at the bottom part of the load port, while the RFID transponder will be embedded on the wafer carrier. SIC73F1 is used as the transponder. It operates at a low frequency of 134.2 kHz and comes with a large memory capacity to store critical production data. This glass transponder is placed underneath the wafer carrier box. Its exact positioning may vary depending on the carrier design. The RFID reader and the load port is connected to the manufacturing system. It reads the data stored inside SSC73F1 transponder and transfer it into the system. One key advantage of using RFID is its ability to support operation even during a system downtime. If the manufacturing system becomes temporarily unviable, the equipment can still communicate directly with the RFID transponder, allowing the process to continue without interruption. Let's look at how RFID brings real value to the semiconductor manufacturing process. First, RFID improves tagging and testability. Each wafer carrier has an RFID tag, which stores important information. This tag is read and updated at every process step. So we already know where the wafer is and what has been done to it. If there is ever a problem, we can quickly track back to the data and find the root cause. It's like giving every wafer a digital passport that records its full journey through the factory. Second, RFID helps with better inventory and production management. Since we are collecting data in real time, we can see how long each process takes and how much work is happening at each stage. This helps us balance workloads, manage equipment usage, and plan more efficiently. It can reduce waiting time and improve overall production flow. And third, RFID makes data collection more accurate and reliable. Instead of relying on people to input data manually, RFID reads and writes data automatically. This means fewer errors and more confidence in the data we are using. Each RFID tag has a unique ID that links all related production info, which is really helpful for analysis, reporting, and continuous improvement. In short, RFID helps us work smarter, faster, and with better control over the entire manufacturing process. Next, RFID in waste management. RFID technology is playing a big role in improving how we manage waste, especially in tough outdoor environments where traditional tracking method doesn't always work well. First, let's talk about the challenge. Waste collection often happens in harsh conditions. Bins are exposed to dirt, rain, and rough handling. In this environment, it is hard to rely on barcode or QR code. These can get dirty, scratched, or blocked, making them unreadable. That's where RFID comes in. With RFID, each waste bin is equipped with a durable RFID transponder. It usually placed underneath the bin, protected from damage but still readable. This tag holds a unique ID for the bin, which is linked to information in the waste management system, like who the bin belongs to, how often it collects, and even how much it weighs. During collection, the RFID reader system installed at the rear of the garbage truck automatically reads the bin ID as it leaves for emptying. There is no need for manual scanning or visual check. The system can instantly log the collection time, location, and bin weight. This helps city or service provider track exactly when and where waste is collected. This process works smoothly even if the bin is dirty, wet, or under pressure. RFID doesn't require a direct line of sight like barcode. Do so, it performs well in this condition. In waste management, RFID technology is used to automatically identify and track bins during collection. Each waste bin is fitted with an RFID transponder that stores a unique ID, following the EN 14803 standards, a European guideline for the identification of waste container. This ensures consistent and accurate tracking across systems and service providers. The RFID transponder used is the SIC 7150, a low-frequency RFID chip that stores the bin ID. This transponder is securely attached to the bin, usually underneath, to protect it from dirt, damage, and rough handling. On the collection side, an RFID reader is installed at the rear of the garbage truck. As the bin is lifted for emptying, the reader automatically scans the RFID tag, even if it is dirty or not visible. The system captures the bin ID along with other data, such as collection time and weight, and send it to the central waste management system. In summary, RFID helps waste management become smarter and more reliable. It ensures every bin is tracked accurately, even in harsh environments, leading to better service, cleaner city, and more efficient operation. Let's move to key management using RFID. Managing physical key in workplace, especially in operation with shared equipment, can be a real challenge. Without proper control, key can go missing during shift change, be taken by the wrong person, or even be used without permission. In this situation, there is often no way to know who took the key, when it was used, or if it was ever returned. This creates serious security risks and disrupts daily operation. RFID technology helps solve this problem by linking secure, automated key management to the process. Each key is embedded with an RFID tag, and these keys are stored in an electronic key cabinet. When someone needs to use a key, they must first authenticate themselves, typically with an access card or employee badge. The system then identifies the key using RFID and log who is taking it and what time. When the key is returned, the RFID reader detects it again, and the system records that transaction as well. This creates a full traceable history of every key movement. This approach does two important things. First, it prevents unauthorized access. Only approved person can take specific key. And second, it supports accountability and smooth operation. You always know who has what, and nothing gets lost in the shuffle between chips. Let's walk through a typical use case of how RFID is used to request and return key. In this system, each key is assigned a unique RFID tag. This allows the system to automatically track who takes a key, when it takes, and when it returns, without any manual logging. Here how it works. When an authorized user needs a key, they first authenticate themselves at the key cabinet, usually by scanning their employee badge or entering a PIN. Once verified, the system will unlock only the specific key they are allowed to use. As the user removes a key, the RFID reader detects the tag and log the action in real time, recording who took it and what time. Next, when the key is returned, the system automatically reads the RFID tag again and log the return time. If a key isn't returned by expected time, the system can trigger a reminder or alert to follow up. This automated process improves security, accountability, and convenience. There is no need for paper log or manual tracking, and no guessing who has which key. In summary, RFID in key management ensures secure access control, full traceability, and better workflow continuity, helping business protect assets, and avoid disruption caused by loss or misused key. ค่ะ Let's recap the key benefit of using RFID in waste management and key control system. First, RFID provide real-time data collection. In waste management, this means you can track the exact location and status of waste container at any time. This helps companies optimize route, improve scheduling, and reduce unnecessary costs, leading to better efficiency overall. Second, RFID enhance security in key management by embedding RFID in key. Only authorized persons individually can access specific key, ensuring that there is no unauthorized use or misplaced key. This adds a layer of protection to important assets and areas. Lastly, RFID offers asset control flexibility. It can be easily integrated with other asset control systems, allowing for varying level of authorization. This means business can tailor access depending on the user, making the system more adaptable and secure. In summary, RFID improves operation, security, and control across multiple applications, offering business a smarter, more efficient way to manage both waste and excess.
Thank you, Prada, for sharing your insight on the solution based on LF technology. And hello, everyone. I am Jason, Customer Application Engineering Manager at Silicon Craft Technology. For the second half of this webinar, I'm going to share you some interesting applications based on high-frequency RFID tag, covering from factory automation, machine and device safety, and some interesting examples from surgical operation. Okay, so let's start with a scenario where RFID help high-speed production line achieve high quality and maintain flexibility. One challenge which occurs at the sorting station is when the sorting station needs to make a decision based on the result of earlier process, not a physical or the ID of the product itself. For example, if you have a product like battery cell with the test result from earlier state, but it cannot be distinguished by ID directly, there might be a couple ways to retrieve those data. The first one might be using the paper-based manufacturing traveler to record the data and sorting it accordingly. While the process is simple and easy to understand, this process is not automated and cannot keep up with the high-speed production line. Another option is storing the data and the test result in the server linked with the barcode or ID. Then at the sorting station, the system can request the data linked by the ID and sorting the product accordingly as well. However, this requires fast data inquiry and could be the bottleneck and reduce overall production speed. Let's see how RFID solution can be benefit in this scenario. As RFID can act like a digital manufacturing traveler which move along the production line like a paper-based one, by attach the RFID to the workpiece carrier as a simplified diagram here, the machine in the earlier state can write the data or test result directly to the carrier and then being read by the sorting station in the later state. This kind of machine-to-machine communication through the RFID tag allow the process like sorting station to be performed without any delay from the human intervention or dependency from the computer network on the factory floor. By the way, there is another simple application which can benefit from the machine-to-machine communication via RFID as well. That application is a tooling usage recording. Because there is many machines that require tooling head switching occasionally and require precise usage recording to ensure consistent quality of the output. For example, mold usage tracking or press die usage tracking, for example. By embed the RFID tag to those tooling head and install the reader to the tooling holder or the main machine. The machine can detect any tooling head changing precisely and can record the usage into the tooling head itself without a need for the online communication to the factory floor. Now we move to another area of industrial use, which is the application related to machine and device safety. There is many industry, especially healthcare, biotech, and chemical sector, which cannot tolerate any failure due to misuse or the human error. For example, installing the incorrect chemical substance tube to the machine or activating the machine during operator still in hazardous area. To prevent such an incident, a foolproof solution is required. For the easy scenario, the component that work with the device or machine could have external power source and allow direct electrical connection to detect the status or the configuration. So the device designer can use simple network like I2C or any field bus to exchange the data between the components. However, there is many application as well, which is some component in the system are passive or does not support any electrical contact due to various constraints. For example, the dimension limitation or excessive corrosion from the environment around the machine. In such cases, HF RFID could be an option because it does not require direct electrical contact, and both tag and reader are still relatively small compared to other technology. Moreover, they can operate under versatile read range from proximity range, which is very close, or vicinity range, which is maybe 5 centimeters or more. So these characteristics of ISO 15693 allow high flexibility to integrate transponder to various systems and various scenarios. As the tag and reader can be applied to various applications to prevent any error from machine setup or incorrect connection, I have few examples to show you here. The first one is a host coupling verification for chemical industry. This picture is a host coupling area, and the picture on the left side is the structure how you integrate HF reader and HF tag to the device. This application allows chemical plant to detect any configuration change made by the operator before proceed the critical step. Another example is the IVD machine or in vitro diagnostic machine and the body fluid analysis machine. This kind of machine normally operate in the laboratory and include many small tubes look like this picture. And because the machine consumes various kind of chemical and fluid, if there is any refilling with the wrong chemical, that could cause a long service interruption and serious consequence. So by adding RFID tag and the reader at the coupling, the machine can ensure the connection before they start the next step. Another example is the fiber optic identification and detection. Fiber optic is the kind of passive cable that can be used in communication device or healthcare device like a laser treatment. So by adding HF RFID to the terminal, the device can detect the connection when the fiber optic has been connected and ensure that all connections are correct before actual use. And the last example is the application to use RFID tag in the safety switch. This one can be used to ensure that all door and window are safely closed before start the machine. However, RFID provide another level of safety compared to another kind of safety switch because user cannot trick it easily. The reader and tag must match the ID itself to initiate the machine. So you cannot bring another magnetic to trick the system. Now let's switch to healthcare industry, specifically focusing on surgical application. One recurring issue in surgery is retained surgical item or RSIs, which occur when unintended items such as a sponge or surgical instrument are left inside a patient after surgery. Despite healthcare personnel being trained to follow strict procedure for counting items in and out during the surgery, error can still happen, and you might hear news about this once in a while. Some medical device manufacturers are addressing this problem with HF-RFID solution. Let's see how HF-RFID integrated to the surgery procedure can prevent retained surgical item problem. Although the occurrence of retained surgical item is rare due to the strict procedure followed by healthcare personnel, the problem still persists, with surgical sponge being the most commonly involved. So let's review the practice to prevent this error. The first one is strictly count in and out object manually. And the second one is using surgical sponge equipped with radio pack material, which can be detected by X-ray or CT scan in the day after. This picture shows the example of radio pack material. This is the example when we saw on the sponge, and this is when the doctor scanned the patient and found the retained object inside the body. Despite this countermeasure can reduce the chance of RSI, the counting error can be happen and still lead to retained item issue and require resurgery and pose the risk to the patient safety. Since this application involves reading through the patient body, which contain liquid and tissue, right? A HF transponder and LF transponder are preferred candidates. This kind of transponder offers superior read-write performance in such an environment. However, surgery typically involves multiple items, which means we need a feature of multiple tag reading or anti-collision feature. This leads to the conclusion that ISO 15693 seems to be the most suitable standard for this kind of application. As a result, many medical device manufacturers have put a tiny tube of ISO 15693 transponder on the RF detectable surgical sponge by adding the small pocket, like this orange pocket and the green pocket in this picture. And they are also developed the large size HF reader, like this device on the picture on the above and this picture on the bottom. This reader can read the body for the entire body and ensure that all item has been removed before the surgery finish. This solution enable real-time detection during the surgery, allow healthcare personnel to thoroughly check all items before closing the wound. And this process significantly reduce surgical risks and enhance the quality of the patient care. The last three applications that I share with you, industry application, safety application, and surgical application, are all based on ISO 15693 technology. At Silicon Craft, we will soon release the new SIC 56NL, our new ISO 15693 transponder compatible with the mainstream product in the market. We have qualified this product carefully across various scenarios, from ISO guard antenna to the tiny inlay. This chip is also equipped with a reprogrammable digital signature, allow you to securely rewrite the signature during deployment. Or you can also rely on silicon craft pre-programmed signature with calculated from hardware security module from the top-tier cloud provider. We are confident that our SIC56NL will deliver smooth integration to both deploying system and your future HF RFID project. Before we closing, let's shortly recap on the application we shared from the beginning. For the first half, we shared the various applications based on LF technology, including the first one, wafer fabrication. RFID can be installed in wafer carrier called FUB for tracking the production, and our SIC73F1 is mainly designed for this application. Secondly, waste management. RFID can be installed inside waste bin for owner identification. Thirdly, electronics key management. RFID can be installed at the key chain for accurately accessing and returning the important keys. While both application, waste management, and electronic key management, either HDX tag and FDX tag can be an option, but our newly launched SIC7150 is also a good candidate for both applications as well. For the second half, I share the industrial and healthcare application related to HF RFID technology, including factory automation, especially the high-speed and high-flexibility one. RFID can be installed at the workpiece carrier and act like a digital manufacturing traveler, allow machine-to-machine communication via RFID. And next, machine and device safety. As ISO 15693 tag and reader are both considered to be small relatively to other technology, it becomes a great option for machine sensor detection and prevent any misuse of the machine. And the last one, surgical operation. As ISO 15693 perform well under tissue and liquid environment and support multiple tag reading, it's become a great choice for prevent remaining surgical sponge or two during the surgery. As the last three applications are developed based on ISO 15693 technology, our SIC56NL can be a great choice for you to consider in your new HF RFID application. And that's all. I hope our presentation has been useful for you to explore new market and new idea. If our product can fulfill your requirement and help you grow your market, please don't hesitate to contact us. Our customer application engineering team is ready to support you.
And that was it. How's today's sessions, everyone? We hope you found insights from both topics valuable and relevant to your work. Before we move into the Q&A sessions, if you want to see more of these sessions from us, we'd really appreciate it if you could take a moment to complete our satisfaction survey. You can do that by scanning the QR code on the screen and share your feedback. It only takes a minute, and it will really help us improve on our future webinars. Once you've submitted the survey, you'll be able to download the presentation slides from today's webinar. Now, let's begin our Q&A sessions. We've selected some great questions from the chat, and we'll go through them with our speakers. All right, and without further ado, I believe that we can move on to the first question. All right. Can SIC73F1 be reused in the wafer fabrication? Ms. Parada, would you like to take that question?
Let me answer this question. The answer is yes, as long as the memory is locked. Generally, SiC 73F1 in wafer carrier will be reused after pass the cleaning process. Our product SiC 73F1 provide with the data retention for 10 years, and it like also product endurance for 100K times.
And moving on to the second question. Which RFID technology is mostly used in the surgical operations, and why is that technology the most used? All right, Mr. Shanson, I believe you can answer that.
Sure, yes. So, okay, so the RFID application that from our study we found in the surgical operation is maybe can divide into two groups. First one is HF RFID or ISO 15693 that we mentioned in this presentation. And another group is the UHF RFID or ISO 18000-6-6C or EPC Gen 2. Yeah, we found both in the market, but from the environment of using, we think HF RFID can get minimum impact from the liquid and the moisture around it. So in this kind of application, we think HF still quite popular actually.
All right, thank you very much. And moving on to the next question. Can the SiC56NL endure sterilization conditions? Mr. Shanson.
Sure. For sterilization, there is two ways to do the sterilization based on the high temperature. Actually, there is another way, like I use radiation as well. But for the temperature itself, there is two methods. The one method, the maximum temperature is 121 degrees. The other one is 132 degrees, but it's shorten the time. So as our chip based on the storage condition, storage specification, we can it can endure up to 150 degrees. So definitely it can pass the sterile temperature at the maximum. Yeah, so that means that you can let SiC 56NL to be sterilized, but it's not the operating condition. So it's during the time that you like a cleaning in the sterile process.
Thank you, Mr. Shanson. And moving on to the next question. Does SiC 73F1 support a high temperature range? Ms. Parada, do you have any comment?
Yes. Referring to the 73F1 specification, the operating temperature can be operated at like 85 degrees, and for the storage temperature is up to 125 degrees. However, we got some example use case that we evaluate in the high temperature length, so 150 degrees, and our 73F1 can work without any problem.
Thank you. We have another question in the
we have a question in the chat. So
Q&A, but do you support the development cycle mean limited quantity of part number? I believe this is for you both, Ms. Parada, Mr. Shanson. Do you have?
Okay, I try to answer first. From my understanding, I think if you have like a new project and you want to try our product with some quantity for some part, definitely we can support. We working with many customer to like a provide sample and co-develop for the like a production. So especially the product we mentioned in this presentation also pretty new for us. We just start to officially launch. So if you're interested to use our product, you can make an inquiry to our sales team or from the email like an info@sic.co.th. I think we can collaborate and give you some sample for you to test run.
Thank you very much. Okay, there are some follow-up question regarding the SAC Secretary F1, right? So he mentioned that I see some people are talking about ISM band 433 megahertz for UHF RFID. Can we create passive RFID tag covering 433 megahertz band?
Okay, I think
Mr. Chair.
I think that's okay. That's an interesting question. But right now, from our understanding, 335 or 33 megahertz on like a ISM band is mostly still the active tag, so it's battery power tag. I think it's related to the certificate, regulation as well. So for our company itself, we just not have the passive tag on this frequency, and we think in the market we not have the commercialized products in this frequency as well. But that's based on our knowledge to this moment. Thank you for the question.
I believe there is no more question. All right, then thank you again, everyone, for joining with us today. And we hope you enjoyed the session and got some new ideas on how RFID technology can level up your operations. And big shout out to Ms. Parda and Mr. Sherazon for the great presentations. And of course, thank you all of you again for tuning in and sending in your questions. If you want to learn more, or if you have some other question, please feel free to drop us a message at info@sac.co.th. We'd love to hear from you guys, and we look forward to staying connected. Have a productive day ahead and hope to see you again soon. Goodbye.
Goodbye.
Bye.